tutorial we'll be going over recursion in C. So, what is recursion? Well, in simple terms, recursion is the ability of a function to call itself. Well, what do I mean by that? Well, let's understand by an example. So, let's create a function, say void recursion, and I provided no arguments. And when I go ahead and define my function void, say recursion, what I'm going to do here is I'm going to print out a line of text that says hello, and then below it I'm going to call the function itself. So this is what I mean by recursion. As we can see here, the function recursion is calling itself at the end. So by just looking at this, we might be able to figure out that this will end up in an infinite loop. So this program will reach no end. So if I go ahead and call my function and compile up my program, I would see that I get an infinite stream of text that says hello printing out onto my console screen. So as you can see here, we get hello printing out endlessly. And well, that's not something that's very desirable in our program. So you might be thinking, well, we want to avoid recursion as much as possible in our program, but that is not so. Recursion can be very much useful. So we'll take an example that's a bit more useful where we can understand the proper use case of a recursive function. Well, we already saw how to calculate the factorial of a number. So let's calculate factorial of a number but using recursion. So I will create my function integer factorial. It's going to take in an integer as its argument. Now if I go on below and define my function, and let's name the argument say x. Now since we don't want to have an infinite loop, we need to have an exit condition. And this is what we call a base case or an end case in recursion. So we already know how factorials work. So if I was to say 5 factorial, it means 5 times 4 times 3 times 2 times 1, right? We could even say that 5 factorial is equals to 5 times 4 factorial, which is equal to 5 times 4 times 3 factorial, which is equal to indeed 5 times 4 times 3 times 2 factorial, which is in turn equal to 5 times 4 times 3 times 2 times 1 factorial, right? Now we already know that 1 factorial is equal to 1 itself. And so from that, we kind of get an idea that we get 2 times 1, 2, 2 times 3, 6, 6 times 4, 24, and 24 times 5, that is 120 as the value of factorial for 5. Now we're going to implement a similar algorithm that does this but using code. Alright, so here our base case is obviously if x equals to 1, we want to return the value 1 as we saw here. Otherwise, that is if our number is not equal to 1, what we want to do is we want to return x times factorial of x minus 1. Alright, so let's see if it's working or not. So here I'll come here and do integer f equals to factorial of say 5. If I go ahead and print out this value onto the screen, we would see that indeed we get the value of factorial 5, that is 120, printing out onto our terminal screen. Alright, so here we can see we get 120 printing out. So that's all correct, but let's understand a bit more how this function is working. So here we are using recursion. As we can see, the function factorial is itself calling the function. Alright, so here we know that whenever we have 1 as an input, we want to return 1 because factorial of 1 is 1. But what's happening here is say we enter 5 factorial, that will be equal to 5 times 4 factorial as we can see here. So this does 5 times factorial of 4. Now what is factorial of 4? So the function is called again. This is not equal to 1. It comes here, so it does 4 factorial is equal to 4 times 3 factorial. And as such, 3 factorial is broken down into 3 times 2 factorial. And finally, 2 factorial is broken down into 2 times 1 factorial. And so when factorial of 1 is called, we get return value of 1. So it becomes 2 times 1 is 2, 2 times 3 is 6, 6 times 4 24, and 24 times 5 as indeed 120. So really that's how recursion works. And so